Hello everyone, welcome back to our channel. In this video, we are going to talk about Terraform meta arguments. When you are working in the real world, using meta arguments is a quite common scenario. Let's see what and all meta arguments are available in Terraform. So if you see the definition, usually we use meta arguments to control how resources are created, updated or destroyed. If you don't understand this meaning, just ignore it for time being. We'll revisit once we have seen the demos. And if you see the meta arguments, we have count, for each, depends on, provider and lifecycle. But for time being, I'm going to demonstrate count, for each and depends on. So to demonstrate it, I'm going to use my AWS console to provision an EC2 instance or VPC or subnets. Based on the meta argument, I am going to use the different demonstrations. So let's jump into my Visual Studio Code to write the code to execute count. So this is my Visual Studio Code and I'm going to create a new file over here. So file name, I'm going to name it as a count.tf. Okay, so it is a Terraform file, so extension could be tf. So usually, as you are aware, when we are writing Terraform code, we need to give the provider. So here I'm going to create an EC2 instance. For that, we need a AWS provider and region we are going to use. Okay, we are going to use US East 1. Okay. So once we have written the provider, then we need a resource block. Okay. In the resource, I'm going to use AWS instance because we need to create AWS instance. And this code is coming because I have installed a plugin called Terraform. So even you can try it out so that it can able to identify the snippet. So in this, we need to provide the AMI. So usually when we are creating an EC2 instance, there are a certain list of inputs we need. Among them, AMI is one of the things. Then instance type, subnets, and few other things. But let's make it simple to demonstrate the count, how it works. So first I'm going to create an EC2 instance without count. So I'm going to use AMI. So this should be in the US East 1 region. So let me go and grab it. So while we are launching an instance, we can choose AMI, which AMI we need to use. So I'm going with the Amazon Linux. So here you can see, and yeah, this is the AMI ID. So I'm going to copy this AMI ID, same I'm going to use in my code. Okay. So once you have provided AMI, then we need to give the instance type. I'm going to use the T2 micro, or else you can see here, you can see here what kind of instance types are available. Of course, T2 micro is available. So let's go and choose the same. Next thing, we can give the tag. Okay, so tags, it is optional, but however, for better understanding, it is always a best practice to use the tags. I'm going to give the name as web. Okay, web server. Yeah, let's make it as a web server. Okay, so this is a simple Terraform code to create an EC2 instance. So let's save this file and let's open the terminal. So new terminal, and I should go inside to Terraform demos directory. Then first command would be Terraform init. So we need to initialize it so that if it requires any modules or dependencies, it is going to clone. So we are using AWS provider, so it is downloading the required providers over here. Of course, it creates under .terraform file. Directory. All right, it took a bit time. However, Terraform init is successful. Then we are going to run Terraform plan. Okay. I mean to say it should give the plan. So Terraform state file has been created. So in the target environment, we don't have any instance. So it is going to create one resource. All right. So let's assume that Terraform apply. Okay. I'm creating this EC2 instance. Let me open over here. If I go to instances, at this moment we don't have any instances. Yes, to create. So it is still creating. Let's go and refresh it over here. Of course, it is creating a web server. Okay. So let's go back. All right. So it has added one EC2 instance. Let's assume that I want to add one more web server. So in that case, what I can do? Usually, okay, I can go and I can copy paste. Okay. So here I'm going to give the name. Maybe I can give the web server 2. Okay. Here also I missed to mention it. Web server 1. Okay. Something like this. And I can provide it same AMI ID and the instance type. So if the instance is same type, then instead of creating one more resource block, we can use the count. Okay, that is the overall usage of count. Rather than repeating the same code again and again, if the same kind of resource, if you want to create more than one, then you can involve the count over here. So instead of doing this one, what I can do, I can just remove this one and I will just add one more entry, that is count is equal to, I need 2 instances or 3 instances. It's up to us. But for testing purpose, we are going to use 2 instances. But another thing is just name. Okay, tag is there, right? So tag we can update. Otherwise, you can see same with same name 2 instances. So rather than that, what I can do is I can give the web server minus dollar count dot index. Okay, so count dot index, what happens over here, for every count it is, this index is going to increase. So first initially it is going to be web server 1 and second time it is going to be web server 2. That's how it is going to add the tags to the EC2 instances. So let me save this file, or else let me launch it 3 so we can easily differentiate it. And again Terraform plan, and here I can change it to just web server. Let it be. So let me save it and I will rerun the Terraform plan once again. So it is going to destroy one instance because we have updated the tag over here, and it is going to create 3 resources if you see. So web server 2, web server, the count index starts with 0. That's why you can see web server 1. Yeah, web server 1, and another one would be web server 0. Okay, that's how it is going to be. But I need to rerun the plan once again. So Terraform plan. Okay, same thing it is going to do, and Terraform apply. So now it is going to delete this instance because the tag is different for this one, and it recreates 3 new instances. Okay, I forgot to give yes. Okay, it has created 3 instances. Let's check it out. All right, one terminated and it created 3 instances, and you can see it is 0, 1, 2. Okay, and even you can check the tags of these instances. Okay, name web server 2, because that's how we have given the tagging. All right, so that is how the count works. In case, so just to repeat once again, in which scenarios we can use count. Count can be useful in case if you want to create same resource type more than one, and most of the parameters are same, or there is no changes of that resource parameters or resource values. In such cases, we can use the count. But let's assume a scenario that I want to create 3 instances, but each instance type should be different. I don't want to T2 micro of these each instance, because one I'm using for web, another one could be DB, another one for some jump server, maybe some other requirement. So in such cases, using count could be bit difficult. I don't say that we can't use it, but rather than count, for each is going to work well. So same kind of scenario, but I want to use three different type of instances. Okay. In such cases, what we can do, maybe as usual, if we don't have the count and the name could be, okay, let's take web server 1 over here. So let's assume that I want two more servers. So I'm just copying it two times. Sorry. So let me decrease the font size so that you can see here three times I pasted it, and I'm going to name it as a 2 over 2, 3 over here 3. Okay, something like this, but instance type could be T2 small, because that is the requirement, right? Medium. So each instance type is differ, though the instance AMI ID is same. Maybe this could be, this is web server 1 and this is web server 2. This could be DB server. Okay, something like this we need to provide. Rather than giving like this, we can use the for each. So in case if we use for each, we can specify these values as variables and we can mention in the instance or resource module. Okay, so let's go back rather than doing this manual way. So I'm just removing these two entries. So to use for each, over here I'm going to write a variable block. So it is going to use the variable block, and I can give instance type. Yeah, that could be the decent name. And after that we need to provide the default values. Okay, so the default I'm going to give for the each type of instance. So I'm going to give as a web server 1 as a T2 micro, and web server 2 as a T2 small, and DB server, right? DB server as a T2 medium. Okay, so these are the values I'm providing over here, and over here AMI ID is same, but we need to give for each. So for each var dot, I'm calling this for each entry. So this is key and this is value. So I'm going to call it as a var dot instance type. So we are calling the var dot instance type. Over here, I would like to retrieve instance type as a T2 micro. Okay. This value we can retrieve it as a each dot value. So just we need to replace each dot value. Okay. So for every time this for each instance, first it reads this record and it changes this value. At the same time, we need to change the web server name. So over here, instead of web server 1, I can give each dot key. So this is key, this is value. This value or tag is replaced with the web server 1, and each dot value is replaced with this value. Okay, let me save this file and let me run Terraform plan. Okay, it is going to destroy 3 instances because the names and the tags are differ, and creating 3. Let's see what and all 3 it is going to create. It is creating web server 2. Yeah, web server 2. Then web server 1 and DB server. So it is going to create these 3 instances. Let's go and apply it. Terraform apply. Okay, it is going to create these instances. Let me go and check it out. So it should terminate the existing instances and create the new instances. So shutting down existing. Okay, sorry, I think it should not be in the double quotes. It should be for each dot value, even over here also. Let me try it out now. Terraform apply. So yeah, I think it is creating. Let's go and see now. Yeah, now it is creating. So while we are using for each, it should not be in the double quotes. I missed it. All right, it's created 3 resources, and if I go and check, yeah, 3 are up and running. So this is how we can use the for each. Even maybe to make it better example, let me take the VPC. So in VPC, usually we should create subnets, right? So if we are creating subnets, there could be public and private subnets, and the CADR blocks also differ. That's why instead of using count over there, though we are creating multiple subnets, it's best practice or easy to use for each. So let me take that example also. So to create a VPC, AWS, sorry, resource, AWS underscore VPC, and the name should be, I can give it as a main, then CADR block, I'm going to give it as a 10 dot, sorry, 10.0.0.16. Then we need to give the this enable DNS support. Okay, anyway, we are not needed at this moment. Just make it as a simple code by adding tags. So I'm going to give you as a name for this one, main VPC. Okay, this is the resource of VPC. Then we need to create subnet, right? So resource subnet, sorry, AWS subnet, and I'm going to name it as a subnets. I can create multiple subnets by using for each over here, but before that, so usually while creating subnets, we need to provide the VPC ID. Over here, you can see AWS VPC dot main dot ID. Sorry. So AWS underscore VPC main dot ID. Okay. Then in this VPC, we need to create subnets. So I'm going to use the for each over here to create the subnets. So before that, of course, we need to define the variables. So variable, I'm going to name it as a subnets, and over here defaults we need to mention. In the defaults, I'm going to give the public subnet 1. I will name it, give the IP range as a 10.0.1.0/24. Similar way, public subnet 10.0.2.0/24. Then private subnet, of course, 10.0.3.0. Then again private subnet 2.0.0/24. Okay, so these we are going to use it. This is a key and this is value, right? So for each we are going to call it as a var dot subnets. Then CADR block. So the CADR block equal to each value, right? So not each key, each value. Then availability zone, we can mention it as in which availability zone it should create. Then tag, I think tag with name is equal to each dot key. Okay, so over here we can able to use for each rather than count. Save this file, then Terraform plan. Of course, now it is going to destroy my EC2 instances. That's fine. So Terraform plan, let's see. Okay, you can see here CADR block is having the issue 10.0.0.0. So that's the issue. As it is auto populating, I'm getting less attention. However, it's good to write the code easily. So you can see here it is going to add 5 resources because 4 subnets and 1 VPC. If I go and check, AWS VPC main will be created, subnet 2, sorry, public subnet 2, it creates public subnet 1, then let me drag a little bit up, then private subnet 2, private subnet 1, and it destroys the previous instances. Okay, I'm okay with this. Terraform apply. So we can apply it, but before applying it, let me discuss about the depends on as well. So over here, if you check, we are creating VPC and subnets. Sometimes what happens, right? By default, or most of the cases, Terraform can understand which resource we need to create first and which should be created later. But sometimes it cannot able to really understand or realize which resource it should create. To avoid such kind of issues, we can able to add depends on. So that should be under your resources. Like before creating subnets, I want to make sure that VPC should be created. So in that case, I can mention it over here as a depends on. Okay, it is depended on AWS underscore VPC main. So VPC should be created before creating subnets. That is the requirement over here. That's how you can use the depends on. It is just purely to make sure that resources are creating in the right order, the dependency resources are created before the current resource is getting created. Okay, now let's plan it again, because there is no change in the plan, because it just give the, because depends on just give a privilege to wait until the previous resource or dependent resource is created. So then Terraform apply yes to create. Okay, all right, it has been successful. And if I go and check my AWS console, no instances, all should be in the terminated state, and go to VPC, two VPCs, and this is our VPC, that is main VPC. And if I go to subnets over here, we can see for our VPC, main VPC, 4 subnets, 2 public and 2 private. So this is how we can create resources by using for each. But just to reiterate once again, if you want to create same resources more than one, then go for count. Even there is a minor changes, we can able to use count. If you want to create more resources, but the values you are going to change for each resource, in such cases, better to go with the for each. Even you can do it with count also, but for each is going to work efficiently. And then depends on, in case if you want to create a specific resource before creating the current resource, then add the depends on to your resource. With that, your Terraform code wait until it creates the depends on resource. In this case, our subnets are going to wait until our VPC is created. If you face any challenges while practicing this, please write it in the comments. I will try to answer best to my efforts. Thank you so much for watching this video. If you like this video, please give thumbs up, and I will see you with another interesting video.